Hello everyone! It's me again, Teacher Joanne. This tutorial is for statistics and probability, a subject which is intended for grade 11 senior high school students in the Philippines. From the previous lesson, so we're not able to meet the last objective, so we will have that for today. So today's objective is, so at the end of the lesson, the learners will be able to illustrate a probability distribution for a discrete random variable and its properties. So this is just a continuation of the last topic, so to meet the last objective. So still topic is random variable. So for discrete random variable, we have what we call the probability mass function, which gives you probabilities for discrete random variables. It can also be represented in three ways. So we have the equation form, tabular form, and graphical form. Okay, so let's have an example. So example is rolling a die. So for the equation, so we have the probability of x equals to 1/6, where x represents the value or the number of dots in a die. So x is greater than or equal to 1 or less than or equal to 6. So to tabulate, so x represents the number of dots. That's what we have on the left side of the table. And on the right side is the probability of occurring the event. So probability of getting a 1 is 1/6, getting a 2 is 1/6, getting a 3, a 4, a 5, and a 6. So all of them has a probability of 1/6. And for the graph, so as you can see, so the number of dots is represented or is placed on the x-axis and the probabilities on the y-axis. And the height of the graph is the same, which represents that the probability are equal for each of the number of dots in a die. And the sum of all the probabilities is equal to 1. Next, we have the cumulative distribution function, which is a function whose value is the probability that a corresponding random variable has a value less than or equal to the argument of the function. So let's have an example. So same example we have is rolling a die. So from the table, you can see on the left is the number of dots on a die. And then we have on the right side, which is the probability. Okay, so for the first, the probability of getting a 1 or less than or equal to 1, so we have 1/6. Next, we have probability of getting a 2 or less than or equal to 2. We have 2/6. So why 2/6? So what are the numbers in a die that is less than 2? So we have 1 and of course we have 2. So from the previous table of the we have the probability of 1 is 1/6 and the probability of getting a 2 is also 1/6. So we just added the two of them. That's why you have 2/6. Next we have probability of getting lower than 3 or equal to 3. So we have 3/6. So just add the probability of 1, probability of getting a 2, and then probability of getting a 3. That's why you have 3/6. So it's the same for the other 3. So probability of getting a 4 or less than 4 is equal to 4/6. Probability of getting less than 5 or equal to 5 is equal to 5/6. Probability of getting 6 and equal to 6 is 1 or 6/6. So to illustrate in a graph, so from the previous graph, so from the probability distribution function, all the height of the graph is the same. But here, so we have the cumulative distribution function. So we start with 1, so which is 1/6. Then probability of less than or equal to 2 is 2/6 or 1/3, and so on. So that's why the graph looks like this. So to understand it further, let's have some practice problem. So practice problem number 1. A box contains 5 balls with numbers 1, 2, 3, 4, and 5. Write the probability mass function and draw the histogram of the sum when 2 balls are taken at a time with replacement. So, para mas madali natin makuha yung sum, so pwede tayong gumawa ng matrix. So we can have the first row and the second row. So first row on top and then the second row on the left. And we have the sum at the corner. So for this matrix, we can just get the sum of the two numbers on each of the boxes. So some of them are already shaded. So these are the probability, which is 0. For example, having first row is 1 and then the second row is 1. So it's impossible since there is only one ball that is numbered 1. So if you draw 1 on the first try, you cannot draw it again on the second draw. Okay, so now let's get the sum. So first, we have 3 for the draw. So for example, 2 and then 1. Then if we draw 3 on the first row and then 1 on the second row. Okay, so 4 and 1 is 5. 5 and 1 is 6. So let's just fill out all of the boxes with their sum. Okay, so we have all the sum. So now we can list the x, which represents the sum of the numbers that are drawn or balls that are drawn, and the probability of x. Okay, so first, what are the sum that we got? So we have 3, 4, 5, 6, 7, 8, and then 9. So to get the probability, so we already have the sum here. So if we count all the results, so there are actually 20. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 20 all in all here on the matrix. So the probability of getting a 3, so just count how many 3s. So we have 2 3s on the matrix. And over the total number of results, so that would be 2 over 20 or 1/10. So same thing for getting a 4. So that's also 2 over 20 or 1/10. Then for getting a 5, so if we count them, there are 4 5s. So that's 4 over 20 or 1/5. Then we have 6, so there's also 4 6. So that's also 4 over 20 or 1/5. Same with 7. Then for 8 and 9, so there are 2 of them, so that's 2 over 20. So that's 1/10. And to graph, okay, so this is how you graph them. So you have the x here on the x-axis and the probability of x on the y-axis. So we just have to plot them. So we have the sum here, 3, 4, 5, 6, 7, 8, 9, and their probability. So 3 and 4, 8 and 9 has a probability of 1/10, and then 5, 6, and 7 has a probability of 1/5. So practice problem number 2. The number of patients seen in the emergency room in any given hour is a random variable represented by x. So the probability distribution for x is given on the table. So we have x. So we have the patient 10, 11, 12, 13, and 14. And then probability of those patients arriving. So for 10 is 0.4, 11 0.2, 12 is 0.2, 13 is 0.1, and 14 is 0.1. So if you would notice, so if you add all the probabilities, that is equal to 1. So find the probability that in a given hour, exactly 14 patients arrive. So when we say exactly, so it's equal to 14 patients. So you just have to look at the table to get the answer. So which is the probability of x is equals to 14, which is equal to 0.1. So therefore, the probability of getting exactly 14 patients arrive is 0.1. Okay, so looking at the same problem, so next question would be, find the probability that in a given hour, at least 12 patients arrive. So what do we mean by at least? So meaning that the 12 is the least number. So what are those numbers? If we look at the table, so we have 12, 13, and 14. So 12 is the least number. So that would be probability of x is greater than or equal to 12 equals probability of x is equal to 12 plus probability of x is equals to 13 and plus probability of x equals 14. So to substitute, so we have 0.2 plus 0.1 plus 0.1 equals 0.4. Therefore, the probability of getting at least 12 patients arrive is 0.4. So for the third question on the same problem, so find the probability that in a given hour, at most 11 patients arrive. So what do we mean by at most? So meaning that it is the maximum number. So from the given table, so at most 11 means we have 11 and then we have 10. So to represent that, so we have the probability of x is less than or equal to 11 equals probability of x equals 11 plus probability of x equals 10. To substitute, so we have 0.2 plus 0.4. So therefore, the probability of getting at most 11 patients arrive is 0.6. So for this lesson, there are terms we needed to remember. So first term is the word exactly, means that it is equal. That is why the symbol we use is the equal sign. So for example, so the probability of getting exactly A can be written as probability of x equals A. And for at least, so you use at least to say that a number or amount is the smallest that is possible or likely and that the actual number or amount may be greater. The form at the least and at the very least are also used. We use greater than or equal to symbol to represent it. Example, so probability of getting at least A can be written as probability of x is greater than or equal to A. And the third term would be at most. So you use at most or at the most to say that a number or amount is the maximum that is possible and that the actual number or amount may be smaller. We use less than or equal to symbol to represent it. Example, probability of getting at most A can be written as probability of x is less than or equal to A. Okay, so we're done for today and thank you. I hope you learned a lot and see you in our next lesson. Bye!